Well, let me start by saying good morning. How are you? Okay. So first question, how many of you have seen Netflix? Awesome. So in Netflix, this weird thing happens, right? Like in many times when you start a movie or a sitcom for most parts, you jump right into the sitcom. There's no title, there's no introduction. It goes on for a bit, it gets you hooked, and only then they introduce the title because they want you to kind of see for a bit before you decide. That's what I'm going to do. I also have some slides that lead into it, so I'm not going to introduce the title. So many esteemed professors here told data is the new oil, and I kind of agree with that. There's lots of data going around in this FMware space, much more than even the traditional machine learning world. If you can see, there's like 247 billion emails, 133 million blogs, and we have 5 exabytes of data. And the economist kind of said the world's most valuable resource right now is data, with the need for all the data being used for building foundation models. But what happens if we run out of data? Just like any other resource, we also have only limited amounts of data, as vast and large quantities it seems to be available. There was a study that was recently done that found that between 2026 and 2032, we might actually run out of data. If you follow this figure from 2020, we've been training data. We've been using the internet data as much as we can, and this is all the internet data that's available. This is all the stock of data that is available. So it's starting to converge. So what do we do? Do we just call it a day, go home, end of boot camp, end of AIware? So many people have been trying to run so many conferences. There are revolutions that are being promised. I would actually like to go home. No, just like any other thing, we try to turn to renewable resources, right? Like we are probably going to run out of fossil fuels at some point. Like, well, definitely going to run out of it. So we're trying to do all the windmills. I was once told that I shouldn't say windmills, wind turbines, and solar panels, and everything. So, but what does it mean in the context of FMware? Say hello to our savior. Can anyone recognize what this is? Yes.
Is it a biblical depiction of an angel?
No, but thank you. That would have been a lot better. I should have used that. Okay, I'll give you guys one more chance. This is an interactive presentation, so you guys have to, get going to make this successful. I didn't have a lot of time to prepare slides, so please. So now, can anyone tell me what this is?
Yeah.
Close, but no dice. No. Sorry? No.
Transmission?
Very close. Very, very close.
Flywheel.
Yes. Who was that? Oh, Danny. Danny to the rescue, as always. It's a flywheel. Sorry? I will introduce I'll now introduce my talk. Now that you guys have bought into it, you haven't skipped intro, so great. So the talk is about the data flywheel for FMware, and I'm Gopi for the remote presenters, and you can connect with me by scanning the QR code. So where does this whole idea of flywheel start from? It started with this book called Good to Great by Jim Collins, where it was more about how to build yourself up. We draw inspiration from weird places, right? So he started by saying, okay, how do I make sure I always get things off the ground and going? I start by following my curiosity to find the big question, do the work, like conduct study, get ideas, concepts, and then I write and teach about it, create impact, sell the thing, move on to the next one. And it's a continuous loop. So we and then Amazon took it and ran with it. First, Jeff Bezos kind of said this is the mantra for their success. And then they also introduced the data flywheel for using all the data available in the cloud and how to conduct customer analytics and then use those insights to sell more products. So this is how a flywheel works. So a flywheel is connected to the crankshaft of the engine in a car or in any engine, I would assume. And the pistons kind of rotate the crankshaft, and that transfers the kinetic energy to the flywheel. And the nice thing about the flywheel is, depending on if one piston goes up or down weirdly, it still distributes the power evenly, and it makes sure that there is energy that is being transferred to the wheels, even when there is low moments of power between cycles. So that's kind of the idea that we want to use here, right? Like we might run out of data. We need to create a flywheel so that we constantly have a supply of data that we can use to not lose our jobs. And I really like the food in the boot camp. I don't want this to stop. So, but what is the first thing we need to make an engine work? Is it gas? But even before this, we need the raw materials, the crude oil, similar to gasoline, to get the gasoline. So the next interactive component, and I really need you guys to work with me because I don't have too many slides. Okay. So who's doing the mics? Gustavo, can you help? So can we identify the different types of data that is involved in FMware? And this is a competition. I have noted down in the next slide different types of data. And I want to see how close all of you guys get. I know it's about 60 versus 1. And I know you're all type A. I'm happy to lose. I'll be glad to lose. So, but hit me.
What's the price?
To be announced later. It'll be good.
Michael?
Pre-training data, fine-tuning data, preference data, user feedback data, crowdsourced data, synthetic data.
Great start.
Great start.
I got more. That's why I don't reveal all my secrets on the webpage. Come on, someone has to one-up Mike.
Oh, no, they don't.
Yes, we have someone here.
Unstructured data, unlabeled data, labeled data, and structured data.
Those are all different types, not necessarily the assets that might go in. Oh yeah, that's true. And also my English is not working very well, so there is a distinction.
Okay, so you have it on the. Let me read from the program. Pre-training data, fine-tuning
Mike
data,
did.
preference data, user feedback data, crowdsourced data, and synthetic data. So do I have an additional piece of data for that? Supply chain data, how about that?
Good. That was very good.
I'll show it in the next talk.
Yeah. I'm very interested in supply chain with all the bomb stuff, so I'm really looking forward to your talk.
Can I say human feedback?
Yes. Good. Hoshang has a.
So data you can crawl freely, very easily, and the data like Reddit, you actually have to have some contract or agreement, or like there's some village, in some poor village, people are labeling in the recent years, and also you hire a bunch of smart people, force them to label it. So many different approaches.
We have different problems. Like, you know, we can force people, and there was at one point slavery, but you know, gold is still gold. So data is like, those would be about the process of the data, but not necessarily the different types of data.
Can it?
I mean, because of the process, the probability of data are different.
Sure. Yeah, I didn't think about that.
Can I say one, Gopi?
Yes.
Telemetry data.
Yes.
I'm trying to help, eh? You want me?
Maybe I didn't know synthesis and preference, but constraint data maybe included that. Constraint.
Yeah.
Ordering.
Last one.
Jimmy.
Last one, Jimmy.
So, in my opinion, so I think everything could be defined as data if they serve for specific usage in the life cycle. For
Yeah.
example, like you think you generate any code, and this code could be run, but it could also be used to train the large language model. So you cannot just say, oh, the code is something is other than data if you want to train on the code directly. So everything is potentially could be regarded as data if you use it for specific steps.
Okay. No, that's fair. So this was my take, and I'm sure, like, I think all of you guys won. The price is probably a better dinner tonight. I made sure the menu is nice, and it was recommended by Michelin Guide twice. So hope the price is good. So these are some of the different types of data that I've been working with and I've been thinking a lot about. And this is a lot more than what we are typically used to, even in traditional machine learning and from software engineering side, right? So we can create most of this data through synthetic methods. And a lot of these techniques start using FM, and they started around 2022. One of the most influential techniques was self-instruct, which gave rise to a lot of other downstream techniques and phi models. And so this is a lot of techniques. And if you look at some of these surveys, it's mind-boggling. I have 35 minutes, and I've already wasted 20 minutes. So I can't cover all of this. And how many of you are professors here? Oh, I'm going to love this. You guys have homework. So please read these papers to get a better understanding of the different synthetic data generation techniques. But I'm not going to leave you guys high and dry. And in spirit of software engineering and reuse, and I also know that some of you guys slept during my presentation yesterday, so I'm going to go and talk about self-instruct and Microsoft Phi models again. So self-instruct, which, as I was saying, was one of the most pivotal techniques in synthetic data generation. So how they went about it is they started by having 175 seed tasks, which was manually created, and they put it in a task pool and prompted the LLM to generate data based on it. And the generated data was then classified as either instruction data or classification data. And then they use a filtering criteria to see if the data is of sufficiently good quality. They used the ROUGE metric, and if it's greater than 0.7, they add it back to their pool, and they iterate this cycle until they have enough data. And the data generated using self-instruct was used to train models like Alpaca. And the other one is about the Microsoft Phi. So what they did was they went about it in a more structured way. They created a curriculum. They did not use curriculum learning. I was wrong yesterday. and so the idea was they took the Stack dataset and Stack Overflow dataset, and they first took 100,000 samples from it and used GPT to and asked it, is it a good educational sample? And if it was a good educational sample, they label the data. And they say they do it instead of using humans because it's just tedious to label data. And then they trained a random forest classifier and used that to label the rest of the data that they had. And they came up with this filtered code language data set. And similarly, they also had 2 other data sets that they synthetically generated, which was a textbook data set by using words from a vocabulary randomly to force diversity in the textbook data that they generate. And they also used, they also created exercises in Python using docstring completion task. And they used that to create the Microsoft Phi models. And they were able to, they were able to use significantly less data and build significantly smaller models that were able to perform as well as large models. Now we have all the data. Crisis averted. Can we all go home? Not all data are created equal though. For the flywheel to work, we need the right kind of data. And it's as it's true in life, we can't like just because it's available or just because we can do it, we can't just punch it in. So the first step to ensure the success of a data flywheel is making sure the quality of the data is high. And once again, as I was preparing these slides and as I've been working over the last couple of years, I see the space moving so fast that there is there's like huge number of survey papers already. And it's impossible to go into any of these individual techniques. So I'm using this overview, and after the end of my talk, I'll give all the references to the papers, and you guys can read to get a better understanding of it. But the general idea is for pre-training, you start by putting some amounts of quality control in place. You deduplicate the data, remove the toxic content, like ensure diversity and representativeness in the data, and create this pre-training corpus. And that's how we kind of ensure some amount of quality for the pre-training data. And for fine-tuning data, where it is, it needs to be more task-specific, we have domain-specific quality measures that we want to ensure that the data follows. And there is enough information diversity, there's sufficient complexity, and this sometimes doesn't get enough mention. Like when we are generating data, it's not enough to just generate easy data or hard data. Yesterday I was talking about curriculum learning, right? That is the whole idea of curriculum learning. We need, we need both easy and hard, and teach the model incrementally from easy to hard, and have enough examples in each category to be able to teach the model what we want to teach. And there are, for different data sets, like depending on if it's preference data, or if it is instruction data, or if it's just traditional fine-tuning data, there are different objectives that we have to optimize for. For example, for an instruction data set, we want the model, we are always optimizing for the model performance to be high. And we are not, like instruction data is not too hard to generate. So it's not always that we are optimizing for data efficiency as much, and we are not necessarily optimizing for selection efficiency. However, for let's say in context learning, you can't just throw all the data you have in the context, because context windows are limited. So there your objective becomes different. You start optimizing more for selection efficiency, more for data efficiency of what you put, because in some of the smaller models, the context windows are even more limited than the large models, right? And even for large models, we can't just put 50,000 examples of code snippets in there. So it's important to know what are our objectives for the different types of data that we are using. And then it's important again, to select the right quantity of data. Yesterday, let's not worry about yesterday. So LLMs, when you fine tune them, if you submit a job to the OpenAI system, it's going to cost you a bunch of money. And usually when you're fine tuning, you have to fine tune it multiple times before you can understand if the model is performing as well as you want. And there's also research that's showing, is fine tuning always efficient? No. Sometimes RAG is better, but unless you try it, you might not know. And that's quite important. So it's important to select the right type and the quantity so that the cost doesn't balloon up, because even when you're hosting the model, fine-tuning is not cheap, and hosting the model by itself is not cheap either. So there are many different methods that aim at coming up with new techniques for selecting the right type of data. But in a flywheel, having techniques to select the right quantity and the type of data is very important. One of the very important papers that kickstarted this discussion was the less is more for alignment. So when everyone was using a lot of, this was right after a few months after ChatGPT came out, and everyone was like, wow, what a great model, but oh, we can never do it because we don't have the resources. And then these guys came out and say, hey, you don't need all that data. Like, you can do it with a lot less. And then finally, this is a favorite one of mine. Even if you select the right type, select the optimal quantity of data, you need to put the data in there that is going to have the most informativeness. So each data point contributes something to the parameters, right? And you want the contribution to be in the right direction, and the delta to be high as much as possible. One of the methods that helps with this is called Shapley. I know it's a pretty complex figure, but the idea is, so the Shapley scores, what they do, Shapley is from game theory. So what they do is they find out in a team, if, like I like cricket. So cricket has 11 players in a team. Not everyone's good, at least not in every game. So you can, using Shapley, you can contribute, if let's say India won the game, out of the 11 people, how much each one of them contributed towards that win. And it's additive. And so what they did in this method was they took this idea and they start finding out how much each data point that you use is adding value to your fine-tuning process. So now do we have all the ingredients? Not yet. Oh, I thought I had an animation. So we can't always just rely on synthetic data either, because recall the discussion we had about we might run out of data. Let's fast forward our timelines. We are in 2032. All our models have seen all the data that's out there in the internet. Now if you're generating data, FMs are still limited by what they saw. They can't just generate something that's completely out of distribution either. And I don't know if we can say all the, if you have trained it on all the internet data, we have the whole distribution of knowledge out there either. So we still need human input to ensure that the diversity and the informativeness and the new knowledge kind of remains. And there was also another research that came out earlier that said that if you keep training your model on synthetically generated data, after a few generations, the model just starts collapsing. So we need human data, but can we trust data from anyone? So I had this very interesting discussion with Prem yesterday. I was talking about how I'm starting to have gray hairs, and you have no gray hairs. And he was like, I have my own dye. Do you want to buy some of it? And I was like, can I just buy dye of a person who I've met, 5 times maybe? Because, like I still I need my hair to stay. I'm still fairly young and all of that. So we can't trust data from anyone, and we need robust processes to integrate the data that we receive from the humans. So, but lots of human data is available though. For example, if you guys have used ChatGPT recently and it's being very aggressive with me, every 3 questions or 4 questions it'll tell me, here's 2 responses, select one. I'm like, I'm tired of giving training data to a lot of people. But and then there's the thumbs up, thumbs down. So there's a lot of explicit feedback data that we can get and implicit feedback data that we can collect in these different platforms. But we need to have robust ways of integrating it. So this work is from someone who works at LangChain, and this is not the version of the work that is currently available on LangChain platform, but an early version of this work is being used by LangChain right now to see how different prompt versions are contributing, and they're collecting data as the people are using the model. So the idea here is, actually the idea is explained better here. So you have a prompt, and then you have an automatic LLM-based criteria generator. It generates a bunch of criteria, and also it allows the humans to review those criteria, generate more criteria if needed, using either code or just natural language. And then on the output, all these criteria are being applied, and you get a confidence score, and you get a confusion matrix of if it's how good it is, how aligned it is, and then you can say if I can use that prompt. And this technique could transfer to different, like they are applying it on prompt and how to use different versions of prompt. But as a technique, this could be applied anywhere. We could have criteria for user feedback if this is the right kind of data that we want to integrate back, and all the nice things. So one of the, I'm not saying this is they're leveraging the whole data flywheel here, but Magic Coder, which is a code generation model, they use a very neat trick that makes sure that they constantly have a good supply of data. So what they do is, so we're not going to stop coding, right? Like as much as AI might be generating code, and Google's saying 25% of the code is AI generated, I'm sure for the next 100 years, if the humankind is alive, there's going to be at least one sad guy fixing a bug somewhere. So there's always going to be, or someone making an open source contribution. So what they do is they take the open source code base, they take just code snippets from it, and they ask the model to be inspired from this code snippet and generate examples or instructions. And they make sure that these snippets are not already present in human eval to ensure there's decontamination and they're not training on testing data. So this is a nice example of implementation of the flywheel, and it was successfully used to train their model, fine-tune their code model, and it was able to outperform most of the other code models. And similarly, the other effort which I spoke about yesterday was, this is a effort by IBM and Red Hat called InstructLab. So what they do is they have 3 large categories. One is knowledge, where they record raw knowledge texts, like curated, but it's like you throw a Wikipedia page in there, and then you have some question and answer snippets on it. And then they have foundational skills like math skills or arithmetic skills or addition skills. And then they have compositional skills that leverage the foundation skills and the knowledge, or it can operate without knowledge too. And they use this to generate the synthetic data. And the neat trick that they're doing here is they realize that human generated data and human input is always needed. So they have this as a crowdsourced platform. So anyone can go make a skills contribution or a knowledge contribution or a compositional skill contribution. And the hope is, as people, and all you have to do to have a contribution is just 5 question answer examples. So for, let's say you want to generate synthetic data for automatic program repair, you put some knowledge in there and then give 5 examples of what are foundational skills, 5 examples of what are compositional skills in terms of APR, and then ask the model to generate synthetic data. It will generate synthetic data for you. and you know that this is based on some of the elements that you want it to follow. I'm almost at time, so I'm going to leave you guys with this. This is our view of how a FMware data flywheel might start to look like. So we have raw data, human annotated. We still haven't run out of data, so we still have raw data. Raw data, human annotated data, and synthetic data. We need aggregation and curation methods from which we should be able to create the benchmarks, the tests, and we have benchmark data, pre-training data, testing, validation, preference, grounding, and all of this, which you can use to pre-train the model or fine-tune the model or align your model. And then you deploy this FM, you evaluate it, you get all of this conversation data, people constantly interacting with your FMware. If your FMware is successful, if not, nobody's going to care. And then people giving you preference data and the performance data that you can monitor, with which you can create memory. And memory is a higher abstraction of data. All of this data, as shown in the green, kind of feeds back. So this flywheel keeps going, and we keep running. So I'm going to leave that slide up. Thank you for listening to my talk. I'm happy to answer any questions. And thank you for being very nice, interactive participants.
Questions?
Yes.
I'll start
Here, just
You keep talking about quality of data and a lot of things, right?
Yeah.
It's not easy, like, how do you decide what is good quality, right? Like, it's not an easy task, and what is good quality today may not be good quality tomorrow, because tomorrow's models might have already seen a lot of synthetic data, right?
Yes.
Like, today's model is trained on non-synthetic data,
Yeah.
and certain quality of synthetic data might be good for today. 2 years from now, when it has seen a lot more synthetic data, the quality of synthetic data might be very different.
Yeah.
Just different in that. But I don't know what quality means. It's a very abstract concept here. And how do you measure? You said some metric there, RG something.
Rogue, I think.
Rogue or
ROUG.
something?
I'm not sure how to pronounce it.
Those are very big approximations, right?
Yeah, that's true. And quality is a moving definition, right? Like, say, for example, in 1950s, doctors were recommending cigarettes as laxatives. But now we know you shouldn't smoke. So similar things will happen, right? Like, right now, we can only operate with the best knowledge that we have, and these are the best metrics we have. And as we grow and evolve, we'll probably know more.
Okay, thank you for your presentation. So recently, I remember there are some researchers who do a lot of experiments on the recursively generated data, and they recently published a paper on Nature saying that AI model collapse when training on those kind of recursively generated data. So I just wonder how you think of this.
How?
So if this kind of recursively generated data will ultimately make the AI model collapse, and then how any prospect you would do for this kind of synthetic data in the future?
We need human-generated data in there too, to ensure that we keep it some sort of fresh and the new knowledge is being inserted always. But as much as that work exists, I think there's also a lot of research that's coming up saying that the claims of model collapse might be exaggerated too. I don't know a good answer, but I think as long as we combine it with enough human-generated data, we might be okay on that front. But I don't have a really good assertive answer.
Gopi, I have very simple question. I'm trying to put the puzzles together, understand whole picture. The output of Flywheel is the synthesis data, and where I can use it, or how is this data? It's a fine-tuned data that I can use it in FMware.
So Flywheel, the idea is the whole thing is Flywheel. So synthetic data is part of is the oil that powers the Flywheel. So all the different data elements are components in this huge machine.
So,
Yes.
so you went back to that slide where you said that there needs to be human-generated data.
Yeah.
And there's some talk that has been going on how there's going to be disruptions and there's going to be new jobs created in the next 30 years that weren't there in the past. Do you think some of those new jobs are going to be creating data? Like
Yeah.
you get paid for, you go to university, you learn everything, and then your job is creating data for these things to do something?
I 100% agree. We already have those jobs, right? Like Scale, Snorkel, they basically run on people generating data, like not as systematically as you said, but maybe in the future there will be a degree or undergrad on data creation or PhD on how to optimally create data. Yes. Yeah, sorry.
I guess in a similar vein, how do you see the legality or the legal side of things where, we can say we're going to reach this point where we're going to use all the data, but more and more people are saying, you can't use my data. This is my high quality data, stay away. How do you see this integrating into the Flywheel?
I have a talk later in the afternoon about bombs. I will touch upon license compliance and copyright stuff there. But a very short summary would be nobody knows. And my feeling, at least, is everybody's running as fast and use as much data as they can before the shoe actually drops or some ruling comes down. So I don't know.
Thank you.
So we'll do Armstrong here first.
Okay, go ahead.
Oh, sorry.
Rock, paper, scissors.
Yeah, I have a very foundational question, and I'm not an AI expert, so please pardon my ignorance.
No worries.
I hear you saying that at some point you refer to a paper that we may run out of data. To me, it appears a little counterintuitive, so would you be able to elaborate? I mean, how?
There needs to be a better way of going back. So if you scrape all the publicly available index data in the internet, we are not talking about the dark web, the index data, there's only let's say a few exabytes of data, right? Like as infinite as it seems, there is a upper bound to that. And once you tokenize all of that, you have 10 power 15 tokens. And right now, some of these models are using 80% of it already, which means that when you finally scrape everything that's there to scrape, you deduplicate things, because there's multiple copies of the same too, right? Like when you deduplicate everything, there's only so much tokens you can generate from that. And after your model has seen all the tokens, there's no more tokens to see, new tokens to see, right? And that's how they will run out. And as they're showing around 2024, this is all the data that's available right now. And we are slowly, around 2024, we are already here.
Yeah, from lexical point of view, yeah, you have tokens, run out of tokens, but you still have people doing things differently. So semantics will still be evolving and changing over time. And
yeah.
So, pardon my ignorance.
No worries. There might always be a little bit left, but it's the very small amount, right? Like if you have seen and consumed everything, how much more, are the contributions to internet going to keep pace with the training? That's the bigger question, right? So today, if I somehow download the whole internet and train my model, in 2 months, is there going to be enough new stuff coming in?
Yeah, I see your point. Yeah, thank you.
Okay, so in the introduction, Hassan mentioned that we're collaborating with this SPDX in the Linux Foundation. Given all this massive amount of information with software engineers and developers was it not too overwhelming? How was that integration to see from what aspect is the FMs or the software, which component could be problematic or what? So how was the information ingested from the other aspect from software engineering space? Because to me, this looks like a lot of overwhelming information. They are not yet there. It's something like you are telling somebody about a promised land where they cannot perceive it right now.
Yeah.
So that's the current state and practice. So how was this kind of information understood at that level?
Which level is the question?
You were working with the Linux
SPDX.
Foundation, right?
Okay. So right now we are working on understanding this space and seeing how we can concretely record it in a bill of material format and what details need to be captured so that some use cases like compliance, vulnerability detection, auditability, supply chain security, and all of this can be accomplished. But we are always going to have room for improvement. And when we did this for the traditional neuralware stuff, it still took us like few years and a lot of back and forth between different participants from like over 50 companies actually to agree on these are all the details we need for many of these use cases. So I know together we hopefully can converge on what helps us, and that's the best answer I have.
Okay, thank you.
Okay, we need to wrap up. So let's. Oh, Danny had a question. Maybe you reach out to him later on. Just because of time, we really need to wrap it up. So let's thank Gopi. Thank you.
Thank you.